The reason it is structural is that the paradigm itself, learning statistical patterns from massive datasets via gradient descent, is missing something that intelligence requires. This is not just an academic debate. The Irys Swarm API was built from the same structural insight. On the 1251 task Harvey legal agent benchmark, commodity models achieved a 17.75% strict all-pass rate through architectural coordination at $1.30 per task versus $50.90 for previous approaches. The models did not change. The coordination did. That is the difference between scaling the engine and fixing the road. The failures reveal the shape of the wall. When an image generator draws a person with 6 fingers, it is because the model learns statistical correlations between pixel patches. It knows that hands have fingers, but it does not know that hands have exactly 5 fingers. Arranged in a specific spatial relationship. It has no model of hands. It has a pattern of pixels that co-occur with the word hand. When a language model confidently states a false fact, citing a paper that does not exist, attributing a quote to the wrong person, it is because the model learns sequences of tokens that are statistically likely. It has no model of truth. It has a pattern of words that co-occur with other words that co-occur with plausible-sounding citations. When a DeepRL agent trained on one Atari game is placed in a slightly modified version of the same game, different colors, slightly different physics, its performance collapses. It learned a policy for specific pixel patterns, not a model of the game's mechanics. These are not separate bugs. They are the same bug, the absence of a causal model. The system knows what usually co-occurs with what. It does not know what causes what. The distinction between correlation and causation is not academic here. It is the engineering bottleneck. A system that knows correlations can interpolate. It can produce outputs that are statistically plausible given inputs similar to its training data. A system that knows causes can extrapolate. It can predict what will happen in situations it has never encountered, because it understands the mechanisms that produce outcomes. Interpolation works within the training distribution. Extrapolation works outside it. And every real-world deployment involves situations outside the training distribution. This is not a temporary plateau. It is a structural wall. And the reason it is structural is that the paradigm itself, learning statistical patterns from massive datasets via gradient descent, is missing something that intelligence requires.